Karsten, thank you so much for joining us. It's been, I think, a little over a month since we first got introduced. And, from the conversations we've been having via email, from reading some of your work, we've been super excited to just get to know you a little bit better in person and talk about the work that you're doing over at Fraunhofer Institute. Now, before we get into all of that, I think generally one of Daniel and I's favorite parts of the podcast and just doing these interviews is getting to know some of the people that are doing some of the work. So I have a couple questions to get us started. And the first thing that I want to know about you, I was quickly snooping on your LinkedIn. I realized that shortly after completing your undergraduate studies, I believe, you joined the Fraunhofer Institute and you've been there for, I think, 14 years now, right?
Yeah, that's correct.
Give us a little bit of context there. What happened? Why the Fraunhofer Institute and what's made you stick around for so long?
I mean, so Fraunhofer in general is an applied research institute. So for us, it may be a bit different if you compare it to the US, but it's situated somewhere between the universities, which are more on the foundational research side, and like industrial research, where you're very close already to product development. And when I finished my studies, I was kind of like, I wanted to continue doing research, but I didn't want to stay at the university because there was a lot of bureaucracy and a lot of like I don't want to say old people, but to some degree at least. And that is why I just kept looking around. And the point is that even during my studies, I already had a side job at Fraunhofer a couple of years back, and I remembered that I liked the atmosphere there. And so, I was looking around, I applied. The topic was interesting at the time. It was more about like communication technology between vehicles, but in the end, I stuck around. So it's been a fun ride so far.
Nice. Well, glad to hear it. Now, when you were doing your undergraduate degree, what kind of research were you doing?
It shifted a bit. I mean, I started out a lot of computer vision and like those kind of things, and media technologies in general. And through a weird sort of coincidence, I ended up then going from computer vision to video streaming. So more to the network side, so distribution of data instead of like the video side. I mean, I was also doing some coding on video codecs and those kind of things, but then I transitioned basically to peer-to-peer networks, which were kind of like a trend at that time, and went more and more into the communication side of things. And in the end, I graduated on communication protocols for industrial like wireless setups mainly.
This seems like a very interesting mix of topics that you worked on. I'm curious, like when you were trying to get into college to pick your discipline and then pick these research topics, did you have a certain goal in mind, or was it whatever interested you at the time, you were willing to just tackle it and see where it goes?
I would say it was a mix of both. I mean, you don't really know what to expect. So I played around with a bit of other topics. I looked into it like computer architectures and all those kind of things, and it was fine. But I always had an interest for media. I mean, I'm a sort of hobby musician to some degree, and I always liked audio and video. And I envisioned maybe someday I will write audio software or something in that field. So I gravitated towards those topics when they were offered. And that is why also during my studies, I started with computer vision and video and a lot of those topics at the time. And then basically transitioned more. This was like, it was a job during like a summer break, I think. I applied for a job and I applied actually for implementing video codecs. And then they said, our priorities shifted. We now do video streaming. And then I started implementing video streaming algorithms and peer-to-peer network formation sort of coordination stuff, and I liked it, and so I kind of like kept with it. And there was also, I would say, much fewer people in the communication field at that time, especially in those like in computer vision, even back then. I mean, now it's even worse, but yeah.
Gotcha. Wow. Well, looking at the piano in the background, it looks like you kept the passion for music alive, which is great to see. And then again, snooping on your LinkedIn, I saw that you're now the head of the department at the Fraunhofer Institute. So what has your trajectory been there during your stay? What department are you the head of as of now? I completely forgot.
Yeah, I'm the head of the Industrial Sensing Systems department. Yeah, well, I mean, I started as a research scientist, working a lot of just like in research projects and also in the industrial projects. So this is also one thing, at least in the, let's say, German landscape, that Fraunhofer is a bit special because a bunch of the finances that we get comes from industry, which is different from our universities. I know that in the US it's a bit like you kind of like have Fraunhofer and universities both in your universities as far as I understand, but in principle I did a lot of project work and eventually became a senior scientist. After I collected enough experience, I led some research projects, and yeah, at some point there was kind of like a bit of a sort of restructuring. How should I put it? I mean, especially in technology, some topics just don't. They fade out and new topics arise. And
right.
When this kind of like process was also happening in our institute, I applied for, at that time, I think it was the head of the department for certifiable AI, which was still like a very broad topic. And yeah, then this kind of like went through some transition phases because back then it was just a small team. And then we realized, okay, AI became much bigger. Also the topic of safe AI, which I'm mainly working on, became much bigger. And then we kind of like diversified into the different application domains.
Right. Now, this safe AI topic is, the most exposure we've had to the work that you've done so far. I feel like in this gold rush era of machine learning and AI, probably the last thing I hear about is safety. Everyone's just super excited to push stuff out. So much so that it reminds me of like, I don't know if you've seen Jurassic Park. It's one of my favorite movies. There's the line of, you scientists were so preoccupied with whether you could or not that you just didn't think about whether you should or not. So I'm curious, like, why did you fixate on this topic of safety? Where did this come from?
I think, I mean, like I said, when you look at my transition from computer vision to communication technologies, and then during my studies, I kind of like rediscovered sort of things that were related to machine learning, applying it first to communication technology, like optimization of different communication technologies, and then basically also faded back into more computer vision topic. But it kind of like at that time, there was already a bit of a gold rush. And for me, I felt like someone rediscovering it, but with a slightly outside view. So not being like already within this sort of let's just push stuff out, and with all the optimism and euphoria that you feel maybe when those things just work, but also with a sort of critical view, kind of like coming back. Is this, especially for some application fields, like, I mean, autonomous driving is most probably the most famous, but there are others as well, where maybe this sort of like, let's just try it out attitude is maybe not convincing for me. But again, I also, in a lot of discussions, I think there's this sort of cultural difference, maybe between both sides of the Atlantic, where on the European side, maybe we are a bit overcautious at times, or at least we like to regulate things, and on the other hand side, maybe there's a bit more like a gravity towards taking the risk of just trying it out and see how it goes.
I would say, at least from our side of the Atlantic, there's definitely that dynamic you mentioned, right? Which is, Farbod mentioned it too, right? It feels like folks are a lot more willing to try it, to see whether it works in production, so to speak, right? They're willing to deploy tested technologies to their general population. And I think from Farbod and I, we appreciate what feels like a lot of nuance, specifically around this topic in the way that your professional background has attacked this. I'm wondering, and I've noticed some posts of yours on LinkedIn and stuff like that, related to the AI regulations in EU. I'm wondering how those relate to your work, if at all, right? Are you, as part of your work at the Institute, are you informing policy in the EU, or are you helping translate that policy in the EU into something that industry can understand? What is your, because you're kind of a beacon for safe AI in Europe, if you will. How does your role play with policy in the EU, where AI and policy, let's say, are more closely interrelated than they are in the US?
Policy is policy, and we're still, like, I would say, research. So obviously, we sometimes work as experts, like sort of expert counsel, people counseling, also maybe on the policy side. But even that is rarely happening. I mean, we work on technical aspects of norms and regulations. Whether there are special things. I mean, I worked also on a German regulation on uncertainty for machine learning, for example, where we just kind of like assembled some guidelines, what to use or what like state-of-the-art methods are and how to apply them. So this is one side of the story. The other side, especially when we're talking about like the EU regulation on AI, right now our task is more to help companies understand what it means. I mean, Germany and Europe are still, I would say, very reliant on small and medium enterprises. So we have a lot of like smaller companies that can't simply afford like 5 data scientists and 2 regulation experts. So they also need some, for example, some guidance. What does it mean for me? Because it's still, I would say, the regulation is very high level. And right now, kind of like we're in the phase where everyone tries to interpret this. What does it mean for my business? What does it mean for maybe future developments that I want to do? Am I impacted by that or not? And this is right now also what a lot of people, I think, are criticizing, that this uncertainty is not the best, let's say, fuel for innovation, because it might just lead to the fact that some people refrain from innovating just out of fear of maybe doing something wrong on that end. And I can definitely understand this sort of like insecurity right now.
No, that makes a lot of sense. And I think Verbode and I appreciate where you sit at the, let's say at the crossing point of academia and industry. And I appreciate that you've gravitated toward that point in your career as well, as opposed to maybe staying at university and doing research there. One of the things we say on the podcast a lot, and folks who've listened to more than one episode have probably heard me go on this rant and complain about it, but I dislike when the smartest folks in the world work in academia and they work so hard to create a new development, but then that technology never has legs to make it out into the real world, or it takes a long time to percolate out into the real world. So I appreciate the work that you're doing that, like I said, I feel like it helps cross-pollinate technology from academia and research to industry right away, which, based on your feedback right there, right? You don't want businesses to feel scared of new technology. You don't want them to feel behind. So, not really a question here, but just a comment and a note of appreciation. I appreciate where you have focused your work, let's say, as opposed to you could have totally been biased toward research and not had any interaction with industry.
Yeah, that's right. I definitely agree. I mean, I think there's no translation. I saw a couple of I think memes when it comes to like great German words that are not there in other languages, and one of the most famous ones I think that comes up again and again is the word doch, which you kind of like can't translate. There's no direct translation, but there's like this. There was even, I think, a slogan of Fraunhofer at some point, just saying we want to make things work in a sense. So despite all maybe objections and despite all the differences, so I'm not here. I mean, a lot of the times when we talk about safety and AI, people say, okay, now there are those scary people, and they say just you shouldn't do this and you shouldn't do that, and we want to forbid anything. On the contrary, we want to enable. So I see myself as someone who wants to enable the use of those technologies, but in a, let's say, more responsible way. Let's put it this way. And I mean, there are a lot of applications where this doesn't matter. So honestly, I mean, if my suggestions on some shopping platform are a bit off, who cares? I mean, this is not a safety critical use case, and this may be annoying, but I mean.
Yeah, like I don't care if Amazon, has some algorithm running and it just makes the wrong recommendation, but I would care a lot if my car makes the wrong interpretation of what's going on around it and it just crashes into Daniel's car. So,
and even worse, if somebody else's car, and I mean, this is the point where we are with the responsibility. You could still argue that, I mean, if you buy a certain brand car and it says it drives autonomously, and you crash, it's still your thing to some degree because you decided to rely on that technology. Right. But especially when we're talking about cars, the impact is also on other people. So I mean, if your car now just like drives into an elementary school group or something, they didn't opt in you buying this car. Mm-hmm. And I think this is where I would start to draw the line. So we don't necessarily need to protect people from their own mistakes, but maybe from others.
Do you have any examples, Karsten, of where, and maybe autonomous vehicles is one of them, but any examples of where you guys have identified a particularly risky area and then tried to help implement some tools or guidelines to try and make AI safer? Because I'm trying to think, and it's really easy for me to put myself in the shoes of someone who's not related with AI or machine learning professionally at all, because I'm not related with AI or machine learning professionally at all. So, for someone like me in the real world, as a layperson, let's say, where can I see your work start to impact my day-to-day life? Where's the nexus of safe AI and where people walk around? Is it at elementary schools and trying to make sure that autonomous vehicles aren't deployed, or are there other great examples too?
I mean, we don't want to make sure that they're not deployed, and the I'd say the sad or the good thing, it depends on your perspective, with safety in general, is that if it works well, you don't see it.
That's true.
I mean, the point is that you don't go out of your house and you aren't necessarily, I hope you are not afraid of being run over by a car, is because we gain sufficient trust in the technology that is kind of like around us, even if it had the potential to harm us in some way. So, and there might be a lot of things that where even if you're not careful, still nothing will happen. It's only when something happens then we realize, okay, maybe here are some issues, and that is kind of like again, maybe the not stressing the cultural thing too much, but a lot of the effort, especially in when we're talking about German car manufacturers, and also, but in general, goes into making sure that those things don't happen. And this is a good thing. I mean, otherwise, like I said, we would be just scared for our life in everyday situations, which is, I think, not what we want.
Yeah. Quickly, before we move on from this topic, because I think it's directly related, Karsten, one of the papers that you worked on, I found it to be really interesting. Again, just like Daniel, I'm by no means well-versed in the topic of machine learning or artificial intelligence, but I'm starting to get there. And this paper was about out of distribution detection, and how the determination of what is unsafe is actually like quite challenging, because as a layman, right, I might just be sitting there and thinking, well, why can't they just make things more safe? It's clear that when a car is doing X or Y or Z, that's an unsafe behavior or maneuver. Why can't you just take that into consideration? But what you broke down in this paper with your colleagues shows that that's actually not the case at all.
I mean, there are several aspects to that. I think there's still, I mean, you don't need, especially for taking actions, you don't necessarily need machine learning or AI in general. I think there are a lot of algorithms that do this pretty well, even today. Where usually the issues come from are perceiving the world, because this is an inherently complex task. You have camera feeds, you have radar data, LiDAR, whatever goes into the feed. And this is something where like we fail with classical algorithms, and where we basically have to use machine learning, and also very complex machine learning. I mean, machine learning is not, some people say linear regression is machine learning, which is neither complex nor scary, maybe to some students, but besides the point, this is still very simple and also well understood. So there we don't have the problem. I would even argue most of the issues that we struggle with in terms of safety and machine learning come from the complexity of the task rather than from the machine learning. We just need to use a complex tool to deal with the complexity of the task, and this makes it very difficult to demonstrate safety on a complete input space. So you can't show a machine learning model all images in the world that will ever occur or that could ever be seen by the camera. So you only present it during training and even during tests with a subset, like a sort of like sample of the real world that you think is representative of the thing that you want to learn. Like, for example, distinguishing cats and dogs, or identifying people on the camera so that you don't run over them. And here, the out of distribution part is basically that we know that if we train a machine learning model, it usually, if we do it well, it works quite well on data similar to what it has seen during training. What is more or less not possible is to extrapolate from that what will happen if I show it something completely different.
Right.
So the standard example, if I train a model to distinguish between cats and dogs, even if I show it an image of a cactus, it will still give me the answer it's a cat or a dog, because that's what the model was trained for, and it will give me an output. And even worse, the bigger the models become, so more complex, the more confident they are in their prediction, even if they are wrong. And that is why the whole topic of out-of-distribution detection basically is identifying inputs that the model cannot handle because it wasn't trained to do so. One, I would say, maybe practical example for that, if you think about the autonomous driving thing again, there is this sort of like rise in e-scooters. I'm not sure how it is in the US, but in basically, I think in Germany, we haven't seen a single e-scooter 10 years ago. And now they are basically everywhere. And now imagine you have a vehicle that was trained on identifying people, maybe even bicyclists and all those kind of things, on data that was 10 years. This is 10 years old. So you don't have any e-scooters. And suddenly they appear. And no model was ever trained to identify e-scooters because basically they didn't exist. And then it is completely unpredictable what the model will tell you. It could still tell you that it's a pedestrian by chance. It could be a bicyclist. It could be anything. And that is the problem with out-of-distribution detection, which is, I would say, one part of making systems that use machine learning, so not just the model, but the entire system or function, at least more reliable in terms of rejecting inputs that are simply so new that you don't know what to do.
And then one more thing that was interesting to me there was, even if you have out-of-distribution detection in place, and you're able to detect that you're perceiving something that you have no real knowledge on, it's still a challenge to then determine, well, is what I'm perceiving, is it a safe condition or is it an unsafe condition? And that opens up a whole, bag of variables to consider itself, right?
Of course, because, in the end, you have a trade-off between safety and, let's say, utility. So, if I'm too cautious and every time my let's say, hypothetical autonomous car sees something that it doesn't know, and this might happen quite frequently, and you have the strategy to deal with it by just like going to the side of the road, stopping and waiting for someone to help, no one will use this autonomous car because it will just stand by the side of the road most of the time, which is not a nice service to have.
Right.
So you always have this trade-off in terms of like how sensitive are you to those kind of things, and what is a good strategy to deal with it. You could still at some point argue that even if it's something you don't know, but it's not on the path that you will go with this said car, it may not be that relevant, but still you might have challenges in predicting what it might do next. So because a lot of those models build on top of each other usually, and you have one model maybe identifying this as a person, and then you have some other component that kind of like tries to predict, if you know that it's a person, what will this person do? But if you already miss that there's a person, everything else that follows kind of like doesn't make sense anymore, right? Because you don't even know that's a person.
Yeah, I think the recommendation that you and the team had at the end of the paper was it's important that the main topic of conversation was deep reinforcement learning models.
Yeah.
And then you said that it's important to have the reinforcement learning agents working continuously together with the out-of-distribution detectors to get better over time. I didn't fully understand how that interaction would work. Could you give us like the explain like I'm five explanation of how that relationship goes?
There are a couple of assumptions under there. So first of all, reinforcement learning in itself, what we considered was a model that was trained with reinforcement learning, but it doesn't have to be. So the main gist was it's a model that takes actions with respect to its surroundings. So it observes the surroundings and the model provides some sort of what to do next. sort of thing, like for example, changing lanes or doing some other actions. And we don't consider any training at that point anymore. So it's not something that continuously necessarily learns in terms of like just the pure machine learning component goes. This is simply because I think a lot of people are currently not the idea of having some product in the world that evolves by itself without testing is still even more frightening than maybe just using machine learning in general.
Right.
So this is kind of like, this was one of the assumptions. But still, I mean, when we detect something that is out of distribution at runtime, so we see something that we haven't seen, this could be due to two different things. It could simply be that it is something so abnormal that it just happens once in a lifetime and most probably will never happen again. Or it could be that we missed something. Either the environment changed, take the e-scooters, something new came up that we couldn't consider, or we did not think about when we collected the data for training and testing that something like this might happen. I think there was a sort of like a web video of a Tesla behind a horse carriage at one point, constantly classifying it as something and then something else. And this is like an example of that. Most probably they didn't consider something like that, or it was simply not part of the data, or at least only a few data points. And so therefore, you can use this detections of out of distribution incidents to kind of like feed this back to your data pool and to the training and to the training environment and say, okay, we need to add more data for training, for testing. We need to consider those scenarios or not, if they're not relevant.
So in this case, using the horse carriage, would the, out of distribution detection detector pick up the horse carriage and say, hey, I don't know what this is. I know I have this much uncertainty with it. Give it back to the pool, say, this needs to be labeled, this needs to be classified, and then keep collecting those data points to reinforce the reinforcement learning agent?
I mean, to provide new environments for the training, basically.
Got it.
So if we're talking about reinforcement learning in particular, but this applies to most of the learning paradigms one way or the other.
Well, and I'll mention, right, again, as a layperson, this is actually quite palatable for me to understand, right? Especially these analogies you're showing me about, if I've trained on cars and bikes, and even if I've trained on scooters, and this is the first time that this autonomous vehicle is seeing a buggy drawn by or a carriage being drawn by a horse, there's definitely going to be some issues there, or potentially some issues and uncertainty there. And so I think it's helpful, and I think it also relates to, in episode 190 of our podcast, we covered a free tool that your team helped develop called Roboscope. It was actually received quite well with our audience, and they were excited about us speaking about, and I think I mentioned it a little bit, but speaking about AI in the context of how do we pause and kind of zoom out and make sure that we're building better tools to build AI? Because we often on this podcast talk about, look at this cool AI tool that does this, look at this cool AI tool that does this. And it was nice for us to kind of pause and zoom out and say, how do we make sure that we're making good, robust AI along the way? Can you kind of explain for someone who didn't listen to episode 190, what that tool is and how it plays into this overall ecosystem of developing safe AI systems?
Yeah, sure. I mean, the main idea, or the how Roboscope came to life, was that we kind of like developed a bunch of methods to evaluate the robustness or the reliability of a machine learning model for ourselves, mainly because this was like kind of like a task that was coming up over and over again, and we thought, okay, we don't just want to measure the performance as basically you would usually do when you evaluate a model, but we also want to measure other properties that give us some more insight in terms of, for example, there's one property that's called calibration that tells you if the model provides some sort of confidence value alongside its prediction, how much can you actually trust this confidence? So is this confidence reflecting like a real sort of probability? I have to put this in air quotes, but something that at least behaves similar to that? Or is it just a number that you shouldn't trust? And those kind of things, there's not one single metric that will tell you this model is safe or not, but you have to inspect it from like very different angles to actually understand where it might fail. Because usually, as I said already, the model doesn't come along by itself. You don't usually just use a model in isolation. It's put in a system. And we don't have to make AI safe. What we need to have is safe systems using AI. And we can actually deal with a lot of the issues that we have with machine learning models and their sort of like uncertain behavior in some, or like unpredictable behavior in some scenarios, by building stuff around it, like monitoring. Out of distribution detection, it's basically a monitoring mechanism that will make sure that not every input goes into your model in the first place without just checking what's going on. And so it is important to understand like what the sort of like ways in terms how your model can fail and how it behaves under certain conditions, to also design then mechanisms how to deal with it. And what we saw again and again is people just measuring like accuracy, which is like the baseline. And so if you have a model, like classification model that tells you like this is a cat or a dog, let's go back to this very simple example. Then accuracy tells you how often are you right, or how often is the model right based on some data. And this is it. And people just pick the model that has the highest accuracy. This is all the leaderboards that you see out there are basically accuracy driven. But this doesn't tell you, for example, if certain errors occur more frequently. Do cats have a higher chance of being misclassified as a dog, while the other way around? And especially if you have multiple classes, we had this with like traffic signs, for example. If you just have something that identifies traffic signs, that some traffic signs are more often confused than others. And you can have a model that has a higher accuracy, but is actually worse for your use case because it makes crucial mistakes in the areas where it shouldn't. Because, for example, it confuses a stop sign with just like a speed limit, 55 or something. And so this is important to understand. And we kind of like just bundled this into a nice web tool. We also wanted to, because we know people are aware that they don't want to share their models and their data and all that stuff.
Right.
So we kind of like thought what could be the least thing they could share. And so they don't have to upload models. They don't have to upload the data. They just basically upload predictions and the ground truth labels. And we kind of like derived all the things that we can measure from there, put it in a nice web report. You get also some recommendations, what to look for, what is maybe critical, what not so much. And this was just like one sort of step, especially for those who maybe start out using machine learning for some tasks to get started. Because, I mean, yeah.
Yeah, that's what I was going to say. What really surprised me was how approachable this tool is, because you don't need to input proprietary information at all. I think the input is mainly just a JSON file.
Yeah.
Which was, I remember telling Daniel, I was like, dude, it's a JSON file. He's like, I have no idea what that means or why you're so excited about it. And I do software testing. I've been doing it for 5 years. So in my mind, quickly, I was like, you could theoretically create a pipeline where there's a new version of the model. You output a JSON file, you run it through this, you get some sort of report, analyze, rinse and repeat. So that was already super exciting to me.
Internally, we have that. So
nice.
I mean, we use this. So basically, the web tool is based on our internal library that we use for all those kind of like testing. It's basically just a front end for some functions of the library, and we also integrated this into other development tools right away. So we use this as part of a sort of evaluation pipeline. I mean, not in the verbose sort of sense that the web tool is, but also to monitor more things than just accuracy. So that's basically how this started.
That's great. And I maybe I'm wrong, but I don't think there's like a really standardized method of doing model benchmarking. And what made me hopeful was, again, because of how approachable something like this is, and it's just free, so accessible to companies that might have 10 people to, multiples of thousands. I was hoping this could be the start of everyone agreeing on some sort of a benchmark or standard to move forward, but maybe that's just wishful thinking.
I'm not sure if we actually need more benchmarks. I mean, there's that. I would even argue to some degree the opposite. That especially machine learning and the research in machine learning is so heavily benchmark driven and basically just optimizing towards like a certain set of commonly agreed benchmarks. That at some point I jokingly said that I think we are now overfitting to those benchmarks. So not necessarily to a single data set, but we're just kind of like all of the methods that we develop are kind of like tailored so much to those few benchmarks. And we know, and this is also one thing that I wanted to mention earlier, because the examples that we had right now, as you said, are very digestible for like the layperson. You can kind of understand if you see a horse carriage, this is something different. So yeah, I can see that. But the main point is that machine learning models behave very differently from humans. And we often make the mistakes that we kind of like, since it seems so intelligent, to carry over the assumptions of what happens if this happens to a human or to a person, that we also think that this might be the behavior of a machine learning model. And in many, many cases, we see that this is not the case. So they continuously surprise us, either by learning some shortcut that we didn't see, and that is difficult to test because maybe it isn't all of the data that we have, or by simply relying on features that for us are maybe not as relevant. There's like, I think 2, 3, 4 years ago, there was an interesting publication looking into like the relationship of shape and texture, for example, for image processing models, and that we humans usually rely on shape a lot if we identify objects.
Yeah.
And so that for us, if something has the same shape or some different shape, we can still kind of like, we can identify that. And this is kind of like where we're good at. But it turns out that a lot of machine learning models tend to use texture much more than shape. And that means that, for example, if you take, I don't know, a cat and apply the texture of an elephant, even though it's the shape of a cat, and I would say 99% of the people, if you show it to people, they would say it's a cat. The machine learning model tells you it's an elephant.
Wow.
And this is kind of like where things get a bit more difficult, because it is it's almost impossible to predict those kind of like issues beforehand without proper testing. And I would say a good testing strategy beyond just throwing a lot of data at your model, because if it's a lot of the same data, the result will always look the same.
You just completely blew my mind with the example of the texture versus a cat being recognized as an elephant. I did not know that. I'm guessing, whenever we do whenever these models are trained, these features that are randomly selected to be the ones that make the distinguishing factor are not what humans would pick, right?
I mean, this was just like one observation, so I'm even not saying that this is true for all of the models. So you could take now 10 of the most famous machine learning architectures, and maybe 6 out of them prefer shape and 4 prefer texture, or the other way around. Or it could just be one minor detail of your training data that leads to one preferring one over the other.
Right.
There are so many variables in there that it is very difficult to predict. So that is by basically every model you want to deploy, you need to analyze very thoroughly, especially if it's like in a context where mistakes might have critical consequences.
I think in the paper you made a point of saying, hey, in classical testing, we can just do white box testing because you know what's going on the inside, whereas with most machine learning models, it's just a black box. So we have to be even more cautious of,
I mean, theoretically, if you have the model, it's not a black box, but it's just a very, very complicated white box. I mean, we know when we implement those models, we know what's going on in there. It's just like millions of parameters or even billions of parameters, and the combination of those again makes it very difficult to understand anything. On the other hand, I mean, if we're completely honest, if you look at software testing, and you mentioned that you are in software testing,
right?
If we have a software product that consists of, 50 million lines of code developed over 20 years by I don't know how many developers, I'm not entirely sure whether this is a system we fully comprehend anymore. But we kind of like assume, because it was built by, I think a colleague said this is the competent programmer hypothesis, that the system was built by competent people, that it should be safe enough to some degree. But I mean, even there is some gray areas if you really look into that.
Yeah, you just really hit home on some of my pain points in my professional day-to-day life. But no, that's absolutely a good point. I guess, Daniel, is there anything else you want to ask about this or no?
No, I appreciated specifically you mentioning this was a tool you guys developed internally for your own work, and then took this and made it available for lots of people to use. So I appreciate that, and I think it ties back to what you were saying at the beginning. And I thought of small to medium-sized businesses where maybe they don't have 5 data scientists, but maybe they have 1. And the one data scientist is working alone to try and develop and deploy our artificial intelligence in a way that's responsible, using this tool like Roboscope. That, they have another tool in their toolbox, so to speak, to make sure that things are robust and things are safe, and identify where potential weaknesses might be. So I appreciated you kind of walking the walk that you talked earlier in the podcast, saying like, let's do what we can to equip all members in industry and academia with robust tools to help them, deploy and use AI in a safe manner. So again, not a question, just a comment there.
Well, I was going to say, this is more of a personal question for me. I'm wondering, Karsten, when I was first, getting into the industry, I came in with these, excited mindset of I'm so happy to be here. I bet it's going to be just like I saw in the movies. Engineering, everything is fine-tuned and perfect, and behind the scenes, everything is just a smooth running machine. And once you realize how the sausage is made, you realize that that's actually just not the case at all. And I'm wondering, now that you have over a decade of expertise in your domain, given the deployment of autonomous vehicle products in the market, how comfortable would you feel about using one of them?
This is a complex question, I think. I think trust has to be built. I mean, without going too much into detail, I recently bought a car that's 1 year old and at least is equipped with a lot of those level 2 like driver assistance systems. And even there, and even working on those things, you still realize that it takes a few weeks to kind of like develop some trust in terms of like, will it now brake automatically when you approach like the rear end of a traffic jam or something.
Right.
And so this is like the one side of the story. And I think this is also what we see. People using those functions, they kind of get used to them. They usually work pretty well. And so I think as a user, I could feel comfortable building this trust over time. So maybe you for some time you pay more attention, and then it just kind of gets less and less. So this is, I think, also human to some degree. The other question is then, would I want them to deploy it everywhere for everyone? And like I said, the impact on everyone who did not make the decision to use this kind of like system, and this is a more of like a responsibility question,
right.
Maybe. And there, again, it's complicated because this has two aspects. On the one hand side, I mean, we don't really know how safe those systems are. And we cannot really measure how safe those systems are. And it might actually be that if I just sit here now and say, we should be careful, let's not use it, that actually by human error, more people are hurt than would ever be hurt by the autonomous cars if they were driving. So because, I mean, we shouldn't pretend that road traffic is perfectly safe as it is right now.
For sure.
On the other hand, I still feel that, you mentioned this earlier, that the progress is so rapid that we cannot really keep up in understanding what's going on. I mean, there was this one, I think, when OpenAI came out with ChatGPT back then, I think there was one statement that they said the engineers were surprised what their thing could do. And I just imagined immediately, I mean, just think like 100 years ago, somebody was building cars and then they drove fast enough and suddenly the car started to fly. And the next day they would sell things called planes. They did not understand why they fly or even just take off the ground, but we realized it works and we're surprised, but who cares? Let's fly over the Atlantic. Then I would also feel a bit like anxious maybe to get on one of those. If my life depended on it. Like I said, I mean, for a lot of use cases, it doesn't really matter because it's a nice toy and it's also very, very nice to play around with it. There are obviously some societal consequences if we think about deepfakes and all those kind of like things, but this is a separate story. And at least from a safety perspective, this is for other people to, I would say, deal with in the first place. But nonetheless, this sort of like surprising nature of this, let's say, called beast AI that we have still makes me a bit like sort of uneasy if we say, okay, we want to have a large scale deployment in systems that could potentially harm people.
Right. Now, I'm wondering, in these safety critical applications like, the world of medicine or autonomous driving, what are some of the ways I mean, I don't know if there are any, but are there any ways that come to your mind that at a high level you could build trust, or are there any milestones or goalposts that you could have to build that trust?
I mean, first of all, if I had a wish list, or if I could just say what should we do, is like we should take more time actually understanding what's going on and less time just putting out the next hype one after the other. I mean, like I said, for less critical products, this is fine. But for the other ones, it's just like we really need. It takes time to understand what's going on. I mean, we're still as mankind, we're still trying to understand physics and what the world is, what's going on around us, and we still haven't figured it out completely. But we are confident enough for planes to, that they fly because there's reasons.
Right.
This is, I think, we need to have a better understanding of what's going on there, and especially now with this sort of increasing speed of developments, like new model architectures come out every, like, I don't know, half a year now or even less, where people just say, where we can throw everything we know about the old ones completely out the window, because the new one might behave completely differently, so we start more or less from scratch. And I think 2 years ago, I attended a keynote at an AI conference, and there was someone saying, okay, we want to understand what's going on with neural networks. And he spent most of his research on neural networks consisting of a single neuron. So not a billion parameters, but just one, because this is kind of like the degree of learning behavior where we can still get some understanding. So this is kind of like, for me, the mental picture is our understanding is at the single neuron, maybe a bunch of neurons sort of interacting level. And at the same time, we're just like throwing a billion images on large models and are surprised by what's going on. And this is a bit of a disparity, for me at least.
So I guess the one recommendation you'd have is, let's take a moment and actually try to understand what it is that we're building on.
Yes, and really favor that, because I mean, this is also something I think when it comes to the ML research community, like I said earlier, it's a lot of stuff is focused on benchmarks, and basically I see this also when we submit papers and also when I review papers and publications. It's like it's very easy, or at least kind of easy, to get a paper published if your numbers are better than the old ones on some benchmark that is commonly agreed. Then it's usually, or often it's not the case. Is it a good paper? Is it like thoroughly investigated? Just the numbers are higher. Okay, looks good, fine. If you have a more in-depth, sort of ambiguous publication that's trying to describe certain things, it's usually much harder to get them published. Because also for the review, I mean, the point is that the whole field grew so rapidly that now we have a lot of people, like students, publishing, but we don't have enough people, like senior people, who can actually judge those publications. So it's even the undergrad students also reviewing the papers. And for them, it's much easier to say, okay, this is a good paper because the number is higher, right, rather than really judging whether this complex argumentation or whatever they did is actually useful or not. And this kind of like discourages people actually from publishing or from working on those like maybe a bit more complicated fields, because I mean, in the end, if you want to make your PhD or something, you have to publish. So if you're in the field, it's publish or perish, now more than ever. And this is, I think, where things could be better. Let's put it this way.
Yeah, it sounds like the incentives are kind of misaligned there. Now, I'm curious, do you think there is a fine balance to hit in terms of keeping up with the momentum and trying to take a step back and focus on the first principles?
I mean, I think so. Like I said, I mean, it's for all those new shiny technologies to learn about them and apply them to less critical use cases is, I think, a very good way to go, because also those applications tell us something. We learn certain behaviors in less critical situations. If I use machine learning to identify like people on my private photos and it tends to misinterpret certain things, then I learn something about the model, for example. And this is like fine because the impact is minimal. But I think I often say that I don't envy those people in the industry right now, because it's so easy to build a prototype that suggests that things are already working. I mean, I sometimes say you can take like an undergrad student, give them some data in a week, and they have a prototype that looks convincing to management. And then you have to go to management and tell them, so now we need 3 years to develop a safe product out of this. But it's already working. So what do you need the 3 years for? And this is kind of like the difficult part, that it's so easy to get like the first 80%, like Pareto principle, basically. The first 80% are very, very easy achievable. But those remaining 10, 20 that you have are so hard. And I mean, you see this by the date for autonomous driving level 4 gets pushed back. I think, I'm not sure. I think Elon Musk was it who said like already 15 years ago, in 5 years, we will have autonomous driving. And I think this is kind of like becomes a recursive theme now. And so those remaining few percent are much harder than people anticipated, I think.
Yeah, I feel like autonomous driving for the masses is reaching the same point as fusion energy. It's always 4 years away, 5 years away.
But it's also, I think, one of the most complicated problems that you could actually tackle with machine learning. And this is maybe the second point. What can we do? We should try to apply this to simpler problems first. For example, where the input domain, so what can actually happen, is much more controlled. Because in autonomous driving, anything can happen. Every person in every disguise can run, lie, jump, whatever on the street. So it's a completely open world problem with an infinite amount of like combinations of things that can happen. But there might be situations or applications where the variation in the data is much more limited, and we're not spending as much effort on developing those, I think, than we do or we did, at least as mankind in the past, on developing autonomous driving.
That's a really good point.
A question I have, and it kind of alludes to things both of you have been saying, right? Frobode said when he cracked into engineering, he understood how the sausage was made. It kind of changed his perception. Karsten, I've had a similar experience working in the automotive engineering field. Right. I work with folks who are in automotive safety, and they say, well, I'll only buy this certain type of car after seeing crash tests, or I'll only buy this brand of car after seeing certain testing. I'm wondering, maybe not to that extent, Karsten, but in your life, you've seen how the sausage is made, and you specialize in understanding kind of even the ugly parts of how the sausage is made in terms of AI and machine learning. Are there any like tangible ways in your life that you feel like you do or don't use artificial intelligence, maybe different from the masses? One thing I think about is like, you said you were disturbed by the fact that engineers they were surprised by how good their development was. And I think someone who's a layperson who also doesn't understand how AI works would also be surprised at how well it works, and for the same reason may adopt it in all portions of their life. Are there any unique safeguards you feel like you put around using AI for certain areas of your life, or would you say you're an early adopter? What is your experience in this field done to the way you might use it in your personal life?
I think neither. I mean, from a technology point of view, I think I would still consider myself not necessarily an early adopter, but like sort of I like playing with new toys. Let's put and exploring them. And I think this hasn't changed with my insight on machine learning. Like I said, I mean, it works surprisingly well for most cases, and I'm also not here to just like scare people of machine learning in those kind of applications, because it can have tremendous benefits. You mentioned medical applications and those kind of things. So I think it is very important to also leverage that. And I personally, I don't see any point where I would feel like I behave differently. I mean, I'm still honestly much more afraid of the seemingly competent programmer. Maybe because I've seen so many programmers in my life, than of the AI. Because, I mean, again, if you have a programmer that just takes stuff from Stack Overflow, copies it together, and is surprised that it works, then the step towards AI is very little.
No, that's I understand a very valid and appreciate fear. That.
Yeah. I think we might be good to start wrapping up. Daniel, is there anything else that you want to chat about?
There was one question I had, and it's kind of a two-parter, but the first part here, Karsten, SAE, Society of Automotive Engineers, SAE International, really, they helped sponsor this podcast episode. They helped set up this conversation that we have with you. I wanted to briefly discuss the upcoming machine learning course that you guys have with them. If you could share a little bit about your involvement, why someone might consider attending. I think it'll be useful to our community because they're also in this group of folks who are engineers, who are makers, who are interested in technology. There might be some folks listening to this podcast right now who might view this as an awesome next step to dive deeper into these topics.
Okay, gladly. So, I mean, it kind of like intersects the sort of between the machine learning and the safety field. So, from practical experience, what we usually see, even in companies, you have the machine learning people and you have the safety people, and they have a very hard time talking to each other. This is when we sat together and we said we want to have like a training that helps bridging this gap. Because if we want to kind of like have a situation where it's not just the safety people saying we won't ever use machine learning, and the machine learning people just say, why are you stopping us? We will eventually, things will work out. We need them to talk to each other, understand each other, and have like a sort of common approach towards, as I said, understanding the properties of a, for example, machine learning based system better. And we kind of developed this also from the two perspectives. So we have like the training is built that we always have one more machine learning inclined person and one with a stronger safety background. So to also translate then whenever somebody has like one of the distinct backgrounds also in the from the learner side, to give those two perspectives and also to bridge kind of like what does it mean in terms of like the other side. What does a safety engineer actually want? Because I mean, they say, okay, here's the requirement. It's 10 to the power of -7 maximum error rate. So do it. And the machine learning engineer says, there's no way I can guarantee that ever. And there the conversation stops. And this is what we kind of like want. We want to break out of this cycle. And this is what the training is for. We teach for like 2 days, understanding each other, maybe in the best way.
Well, and that sounds compelling, and definitely from someone, like I said, who's even not professionally related with artificial intelligence at all in my day job. This definitely seems like something I'd be interested in. But one of the things I wanted to ask, kind of as a twist to that, is Karsten, you're essentially now becoming like a teacher, right? A teacher in AI. Have you ever envisioned yourself becoming like a teacher or a professor of this course, or is this something you kind of stumbled upon? Is that something, you thought, well, I'll gain enough expertise and one day I can teach the masses, or is this something that, you've accidentally gained enough expertise and happen to be good enough at speaking about it that they ask you to teach everyone?
I think the funny thing here is that a lot of people in my family are actually teachers mainly, or were teachers, mainly high school teachers, and so not necessarily like university teachers, but on those kind of level. And this is kind of like when I was younger, I was always saying I never want to become a teacher. Because it's kind of like I saw a bit also maybe what they're struggling with, and also I mean, you as a kid you want to you want to distance yourself maybe from your parents, at least in some aspects. But over time I appreciated at least sharing the knowledge. Let's put it this way, and also building those bridges between maybe seemingly complicated topics. And this is also one of the things that I really like about like being now head of the department, because I mean internally I do basically the same thing. I mean, for the most part I'm just a coach for the great scientists that we have, also helping them to kind of like unlock their potential and find out new ideas. So a lot of the things that we talked about basically came out of their work, and I was just there on the sideline saying, hey, cool.
I appreciate that. And I actually have a very similar story. So my mom growing up was a preschool teacher, and I always said I would never become a teacher. I appreciate all the dedication she has to make sure that and especially at such a young age, make sure that everyone actually learns something, even though they're so young. And then I was having a conversation with my wife, Nellie, actually last night, and I was talking about how much I enjoy the podcast and the fact that we take complex topics and try and make them easy for other people to understand. And we're talking about teachers, and I kind of had a realization, like, I think I really enjoy teaching, and maybe at some point I'd love to become a teacher. So a similar line of thought there, Karsten, but I appreciate you also entertaining my question here about the course that's coming up. We'll link in the show notes in case folks are interested, an opportunity for them to register or check out more details about the event. If you like hearing more of Karsten and less of Forbode and I, that's a perfect opportunity for you to listen to just him without our voices.
Absolutely. And we'll make sure to link, Karsten, I know you got a LinkedIn profile. We will link the Fraunhofer Institute. Is there any other social media, ResearchGate that you want to share with people to find more of your work and what you do?
We have the Safe Intelligence blog as an institute, so where you can also find just more digestible, more digestible than publications in terms of papers of the different research fields of our institute. So if you Google or use the search engine of your choice for Safe Intelligence and Fraunhofer, then you should be able to find it quite quickly. And yeah, we try to keep it up to date and also with the new stuff.
Awesome. We'll link it in the show notes too, just to make things easier. Karsten, it's been an absolute blast talking to you. I hope we see more of you. I'd love to stay in touch and hear about all the work that you and your colleagues are doing in the future.
Yeah, it was a lot of fun talking to you guys.
Yeah, awesome. Pleasure. Thanks. Appreciate it, Karsten.